Good morning, everyone. This is Math 2008. We are going to start working on Chapter 3, Section 1, which is 3.1. Hopefully, by the end of the lecture, you will be able to do the problems from 3.1. Now, in this section, there are a lot of things going on, but I'm going to highlight the most important part, which is called bases. Okay. Now, I'm going to get to bases, guys. Okay. But let's try to understand this symbolism, which you already know. Uh, so what is this? We are saying 2 raised to the power 3 is simply 2 written 3 times and multiplied, which is 2 times 2 is 4, 4 times 2 is 8. So there are n factors, and a is the number, a is a natural number, a is any number, n is any natural number. So you can get 1, 2, 3, 4. So a to the n is defined as follows. And here is an example, which you kind of knew. Why do we care about this notation? This is called the exponent. The 3 here is called exponent or power, and 2 is called the base. Okay? 2 is called the base. Now, we're going to talk about another type of base today, not this type. Interestingly enough, it's in the same section. It's okay. Base, and the power is called exponent or power. And the power, I'm going to write it on top. Okay. Now, that's all we kind of need to know from this box. Okay. So we are going to talk about bases of numbers. What does that mean? All right. We're going to first talk about base 10. The number we use is called Hindu Arabic, and it's based on the base 10 system. Well, let's see what base 10 is. Okay. Let's see what base 10 is. And we're going to talk about other bases. So be a little patient. Okay. So look at this number. Look at this number. Let's make it up. Let's make up something. Okay. Let's say I am interested in 4,527. Okay. So this is called the units place, tens place, hundreds place, thousands place. Units, tens. Let me write it down. So starting from left, okay? Units, tens, hundreds, and thousand. So and 10,000, so on and so forth, okay? Units, place, tens, hundreds, thousands, okay? Let's start from the right, all right? 7 is the units place. What does that really mean, guys? It simply means this number. Okay, first let's observe the structure here. I have a cube, and this is base 10. Let's write that down somewhere here. Okay, that means if this is 1, I take 10, I take 10 copies of 1 and make the next one, 10 of them. Then I take 10 copies of the next one, make the third one, which is 100. Then I take 10 copies of the third one to make the fourth one, which is 1,000. And the next one, you will take 10 copies of 1,000 blocks and stick them all together, and you'll make the next one. So now this number tells me, how many of these do I have? How many of these do I have? How many of these? Well, that's easy. This tells me I have 7 ones. Sometimes we say longs, 1 long, and 2 longs, 2 longs, 2 times 10, and 5, they're calling it 5 flats. And the last one is called a block, and I have 4 blocks. Now, you don't have to say it that way. Basically, what we are saying is we have 7 ones, 2 copies of 10 unit sticks, 5 copies of 100-unit slabs. This has 100 units, the second one, sorry, the third one from right. And the last one, I have a block of 100 units. I have 4 of those. Now, if it's base 10, to make the next unit, you take the previous unit and get 10 copies of it and make it. Okay. So guess what will happen in base 5? You will use 5 copies. Let me go back and so let me go back and put it here nicely. So we don't write a base 10 like this. We don't. 4,527. We don't stick a little base. We just don't. It's not necessary. Okay. We don't do that. Okay. It's unnecessary. If nothing is in the subscript, it's base 10. But when we use another base, we use a subscript. Let's stick to base 5. And the way I will have to tell you, I will say, I'm talking about base 5, and let's change the number to 2, 1, 3, 4 is good enough. Let's see what this would look like in base 5. Now, you will see a lot of questions that will say, convert this base to base 10. What is it in base 10? Now, I'll do some of the problems, so don't worry too much. Okay, so we're talking about base 5 now. Let me get the base 5 blocks. They are here. Again, I don't like those words flats and blocks. I'm just going to say 1 unit, 5 units, 25 units, and 125 units. So look, for base 10 block, I start with 1 units. I took 5 of them to make this. I took 5 of these rods to make 25, which is a slab. And I took 25 of these to make this, which contains 125 unit cubes. Now, having said that, guys, you always want to go back to base 10. So we're learning how to convert a number that's not in base 10 to something or to a number in base 10. If I know the subscript is 5, it's in base 5. Okay. One more thing, guys. To write any number in base 10, you need 10 symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start with 0. To write any number in base 5, you only need 5 symbols, starting with 0. 0, 1, 2, 3, 4. All right. So if you see something in base 5 and there's a 5 here, there's something wrong. There's a typo. Let me go over it once again. To write any number in base 10, you only need 10 unique symbols, and they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all we have in the Hindu-Arabic system, right? To write any number in base 5, no matter how large, you need 5 symbols, and they will start with 0, 0, 1, 2, 3, 4. All right? Now, this tells me I have 2 of these. Now, I'm going to do something funny. All right, so I have 2 of the units. I'm going to take them here. Okay, so far so good. I have 2 of the unit ones. I take them here. Now, I don't have a lot of room, so I'm going to go down. It doesn't matter. We're just counting the cube. How many copies of the long ones do I have? According to my picture, the second digit is 1 stick. I only have 1 stick. I'm going to take 1 of them. One of them. How many of the slabs do I have? Well, I have 3 slabs according to that symbol. All right. How many of the blocks do I have? I have how many? 125 is a big block, and I have 4 of them. We'll see where we put them. We'll have to find some room. Hide this guy here. I need 4 of them. I don't need this anymore, right? Let me get rid of it completely because I need the whole screen. Now, I have represented this number now, okay? Four of those big blocks, each block is 125. Three of these slabs, each is 25, okay? One of these rods, each is 5, and then two loose ones. Well, how many cubes do I have? Well, I'm just going to use my calculator, if that's okay. So how do we do that? Remember, I have four. I don't want to hide it totally, but okay, that's fine. I'll move it around. So I have four of these. How do I write that? 4 times 125. All right. This 4 is this digit, and 125 is how many cubes are in each of them. Then the next one, I have 25 here, but three of them. I'm going to add 3 times 25. Then I'm going to add 5. There's only one of them. I can multiply 1 times 5. I'm just going to add 5. Then I have 2. I can easily count plus 2. 525. So this is same as 525 is based in base 10. I'm going to say this is same as 525 in base 10. Now, this was nice because I had a very nice picture. And this slide that I used came from a book. Of course, you can draw your own picture, right? And make a new base something. I think I have base 3. I'm going to do a problem with base 3 for you guys right now. But here is how you convert a number in base 5 to a number in base 10. And we're going to do the opposite too. We're gonna start with a number in base 10 and convert it to a number in, let's say, base 3, base 4. Let me grab some pictures for base 3 and see what we can do. Let me get rid of all this. All right, let's say this is a number in base 3. Now, why am I choosing base 3? Well, I have a picture. And I'll do one without a picture because you kind of need to see that. I'll tell you, it's not really that bad. I'm going to convert this number in base 3. Again, if you want to write a number in base 3, you will need 3 symbols. In this case, it'll be 0, 1, 2, 3. That's all you need. And I'm calling it X because I don't know what it is. I got this from the internet. Okay, but it'll come in handy. All right, so base 3, these are called base 3 blocks. The first one has 1 cube. The second one has 3 cubes. The third one has 9 cubes. The next one, the fourth one, has 27 cubes. Now, how do we do that? Well, 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. That's what base 3 blocks, that's how base 3, that's how base 3 blocks are made, right? Nothing too fancy. Now, instead of writing using the pictures, I can just pretend this is a 3, this is a 1, this is a 3, this is a 9, and this is a 27. That doesn't bother me. I like that. I like that. The picture is here. These pictures are hard for me to cut, so I'm going to leave them like this. So the picture can be here. Excuse me, I had to go to get a tissue, okay? So let me see. I don't need this. I'm going to make a table, and you're going to see you can use the table. The table will come in very handy because in the book they will use base 11, base 12, all those things. So I have 4 positions. So I'm gonna make a little table with like this. Okay. And the first one is this one, 1. I'm gonna put 1 here. The second one is 3. The third one is 9. The next one is 27. But let me do one more thing. Let me do one more thing. Instead of 27, remember we learned the exponent notation? I'm gonna write 3 to the power 3. Well, this won't let me write it, but I'm going to write it on top. So give me a second. Instead of 27, I can write 3 to the power 3. Okay, it's the same. And instead of 9, I can write 3 to the power 2. Sure. Instead of 3, I can write 3 to the power 1. Generally, we don't put a 1, but I'll put it just to emphasize. Instead of 1, I can write 3 to the power 0 because any number raised to the power 0 is 1. So do you see any patterns? Of course, hope you do. 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3. That's how the base 3 blocks are made. The first one is always 1. Doesn't matter what the base is. The second one is 3 copies of that. The next one is 3 copies of the previous one. The next one is 3 copies of the previous one. Now, this number 1, 2, 1, 2 goes here. That's what I have, guys. So how many units do I have? How many unit cubes do I have? 2 times 1, okay? 2 times 1, 1 times 3, 2 times 9, 27 times 1. You add it all up and you'll get the number in base. You will get the number in base 10. So let's do it. Now, 27 times 1 plus 9 times 2 plus 3 times 1 plus 1 times 2. I'm getting 50. So this number in base 10, let me double check once again. 27 times 1, 9 times 2, 3 times 1. I think I got it right. Now, this number in base 10 is now 50. And we don't write subscript base 10. We just don't, but it's understood. With me, guys? Now, we're going to do something different today. So now, let's say I want you to convert 75. Now, let me take, okay, 54, 60. Let me take 60. Okay, we can convert 70, convert 75. It's not a big deal, but I'll need more symbol. And maybe I'll do one like that. Don't worry, but not right now. So I want you to convert 60, which is in base 10, to a number or to the number to its equivalent in base 3. Okay, so what does that mean? 60. So basically, I am going to trade these blocks. Okay, how many of the big ones do I need? We always start with the one on the left. Okay, and you're trading. Look at it this way. You're trading. You don't want something very cumbersome. You don't want a lot of loose cubes. Let's say you don't like loose cubes. Okay, they're too hard to manage. So somebody gives you 60 gold cubes. Okay, you got 60 gold cubes, but you're going to a country. Of course, it's all made up situation. You're going to a country where you can carry gold cubes, but they have to be in base 3 blocks. And you want to minimize the loose structures you carry because they'll rattle. All right. Now you're asking yourself, I have 60 of these loose ones. Okay. So I can certainly trade 2 of the big ones. I'm going to write 2 here. I'm certainly going to get 2 of these. And I don't want to take a lot of loose gold cubes. Okay. They rattle too much and they're annoying. And they're taxed individually. So I'm going to put 2 here. All right. Then you take your 60. Okay. Bear with me. You took your 60. You subtract 2 times 27, which is 54. And that's 6. Now, you are not going to you only have 6 loose gold cubes. You're not going to be able to get any of the second ones. So what would we do? We're going to just say, I need 0 of those. I don't have any. Okay. This, of course, you can get 6 loose cubes, but you don't want that. You don't want a lot of loose gold cubes hanging around in your bag. So you will get 2 of these. you will get two of these, and you're kind of done. And you will be generally write 0. If you don't need something, we write 0. Basically, for 60 loose gold cubes, you will need two of these and two of these, and you'll be all set. Let's go back and double check. 27 times 2 is 54, and 3 times 2 is 6. And 54 plus 6 is 60. We're good. I don't think we made a mistake. Now, in base 10, in base 3, it will be written 2, 0, 2, 0. I'm going to do a couple more. Okay. I'm going to do one where it's a little bigger than 60. Let's see what we can do with 100. With me? Ready? Awesome. Let's say I'm going to write this X. I'm going to write X here. I have 100 loose gold cubes. And look, the next one, the next structure, I don't know how to draw it. Let me try. I don't need this. It'll be a little sloppy, the drawing, okay? So bear with me a little bit. To make the next structure, which I don't have in my picture, but I actually don't need it either, but I'll make it, but I'm gonna just go by this. All right, guys, I'm gonna make my table. The first one is 1, the second one is 3, the next one is 9, the next one is 27, and the next one is 3 times 27, which is, I believe, 81. Now, you don't need the structure. It's not a bad time to transition to a table where you don't have a structure. But as promised, I'll try to make a sloppy drawing if I have to. So I'll try to see what I can do. So I need 3 of these big ones. And it's going to be sloppy. 3 of these glued together. I don't know how I'm going to glue them, but I'll certainly try. All right, we have something, right? So the next structure, which was not in my picture, is now 27 times 3, which is 81. Now, again, you have you have 100 loose gold cubes. All right, guys? You are going to a country where they'll let you take the gold cubes, but gold cubes must be represented in terms of base 3 blocks. And every little loose piece you take is taxed. So you want to minimize the number of loose structures you carry. So the first thing you would ask, how many of these do I need? Well, it's 100. And this structure has 81 cubes. You need one of them. Put one here. Okay, from 100, 81 is gone. You have 21. Let's write that down. You have 21. You have 21. Well, you don't need a big block of 27 cubes. That's too many. You only have 21. Nobody is going to give you extra gold cubes, right? You have 21. So you're going to get two of these. That accounts for 18. So you're left with 21 minus 18. Sorry. Yeah, that accounts for 18. 21 minus 18 is 3. Right? And here you will need one of those, and the rest are 0. You will have to write them. So I don't need this anymore. So this is 100 as represented in base 3. Excuse me, is 1, 0, 2, 1, 0. Let me see if I made a mistake. So guys, these are the main things from this section, okay? This chapter has Mayan numerals, Roman numerals, and we could do it. It's a little hard to do online, and that's not something you will be teaching necessarily, but base 10 blocks you will be teaching. So you want to learn it very nicely. Okay. You want to do the problems in the book. I will take one problem from your book that is kind of tricky, and I will do it. With me, guys? One more thing. One more thing. I'm not going to use the pictures anymore. I'm going to use a table like this. By the way, 81 is 3 to the power 4. You can write it down. Okay. So let's do a problem from your book. It's going to seem a little difficult, okay, but we'll do it. We'll survive it. And again, if you need help with something, you ask. Okay, this is tricky. So I'm going to do number 17. I'm going to do a couple of parts. I may not do all the parts. No, I'm going to do part C. What's part C? Find the numerical preceding and succeeding each of the following numerals. All right, guys? So I'm going to do A and C. I'm going to start with C. This is 5, 5, 5 in base 6. Huh. I'm sorry. So, what's going on here is I am going to find out what it is in base 6, and then I'm going to subtract 1 from it, and then that I have to write it in base 6. Okay, it'll look a little weird, but bear with me. 1. I just need 3 of them, so I have 3 positions here. So this one is going to be 1. This one is going to be 6. This one is going to be 36. 6 square is 36. Okay. Now, I have 5 of these. I have 5 of these. And I have 5 of these. Now, my calculator would tell me that simply amounts to, okay, this one is not too difficult. One less would simply be this, 5, 5, 4. Okay. So I'm going to say one less is in base 6, of course, 5, 5, 4, and base 6. Okay, that's preceding. Okay. One more is a little tricky, guys. Okay. One more is a little tricky. If you add one more loose piece to this 5 will become a 6. Okay. You can't have, if you have 6, you're gonna go here. You will trade this. This will become 0, and this will become a 6. Oh, that's a problem. You can't have a 6 there. So 6 of 6 is 36. So this is good. I'm going to make it 0. I'm going to go here, and this will be 6, right? Let me go back and see it once again. Okay, they got us, isn't it? But I don't think I messed up. Let me explain it once again. Okay, now 5, 5, 5, 5. All right. If you're going to add one more cube, these 5 loose ones will be 6. Actually, guys, what I'm going to do, I'm going to show you all the steps. So I will have 6 here. I'll have 6 here. Well, that's a problem, guys. I can't have 6 loose ones. So I'm going to say, okay, fine. I'm going to trade that with stick of 6, a stick of 6. Okay, so that will make this column go up. Well, I can't have 6 sticks. So what am I going to do? I am going to trade it for a slab of 36. So this will be 0. This will be 6. Still a problem, isn't it? I cannot have 636. I will trade it for 6 copies of 36. And for that, I'll create a little column here. Unfortunately, I'll have to kind of write it here. 6 times 36 is, hopefully my calculator will help me, 216, okay? I will need a little room, 216. I need one 216, and this will be a 0. This will be a 0. It's like adding 1 to 999. You will get 1,000. You'll have to have a new little slot for it. Okay, so that's part C. I'm going to try part A. All right, you may be wondering, what is E? Okay, remember guys, we discussed that for base 12, you will need 12 unique symbols. You will need 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can't write 10, that's 1 and 0. We're going to write E. And then you will need 11. We can't write 11, that's 1 and 1. That'll be confusing. We write E, and T will be, let me write it down here. T will be 10, and E will be 11. Now we can use 10 and 11. That's going to confuse us because of the position. So let me explain number A. Okay. I know it's a little challenging. E, 0. Okay, what this is saying, base 12. This is 1, this is 12, this is 144. Right. And this is 0. I have 0 of those. I have 11 of these, and I have 11 of these. Now I may need the next spot. I'm not gonna worry about it yet. I'm gonna get rid of this. Now, you can do it one way. You can always convert what is given in base 10, then subtract 1, then add 1, and then convert it back to base 12. That's way too much work. But this one, the one that is succeeding is easy. Let's do 1. Succeeding means you're adding 1 loose one, so it'll be, and you don't want to write 11, you can write E, but here it doesn't confuse me on the table, right? But if I write it as a number, this will confuse us. 11, if you don't like 11, you're like, we just defined 11 as E, write E. I don't see a problem. All right, so if you add 1, this will be 1, okay? 1, this will be E, this will be E. So my answer for succeeding, for the one that's succeeding, is going to be simply this. Not that bad. EE 112. Now, the preceding one is kind of interesting. All right, guys, let me go back and try to do it here. Preceding means I have to take away a loose cube, a loose piece. Now, I cannot take away a loose piece from the first column on the right because I don't have any. I have to take it away from 11. From 11, if you take away 1, you're going to get a 10 here. Of course, we're going to write T. And that's going to take care of it. Let me think about it a little bit. I had 11. I'm going to get rid of 1, and that's going to be, yeah, you have to be a little careful. Okay, so I will bring my 11 here. I had E, right? I had 11. Let me go over it once again. And this was E. Okay, so I have 11 of these 12 ones, isn't it? 11 of these, 12, a stick of 12, a stick of 12, a stick of 12, 11 times. Okay, I'm going to take away one of those 12 sticks, one of those 12 sticks. Okay, and I will have 10 of those sticks here. I'm going to put a T here. I'm going to bring a stick of 12 loose cubes here, and I will get rid of one. I will have 11 cubes left in my stick, so it will be this. So this one will be TTE. Isn't that fun? I'm going to prove to you I didn't mess up. Sorry, ETE. I'll prove to you I didn't mess up. ETE. Okay. All right. Now, I am going to get all of them in base 10, and I'm going to show you that these are consecutive numbers, okay? This is the preceding, and this is the succeeding, okay? I'm going to use my calculator. All right, guys, so this is in base 12. So this will be 11. E stands for 11. 11 times 144 plus 10. T stands for 10 times 12 plus E stands for 11 loose ones. So I'm getting 1715. That turns out to be 1715. Okay. All right, in base 10. Let's look at this one, EE0. Let's see what that is. It seems very counterintuitive. So the first one, 11, 144, and 11, 12s, and 0, 1s. 116. So far, so good. This is 116, so I didn't mess up. It's actually 1,715, 1,716. All right, now we're getting there. What about this one? Well, let's try that one. This one is 11 copies of 144, 11 copies of 12, and then 1. So 1,717 is the third one. It's a little hard, guys. You want to read the section very well. Hopefully the videos help. If you need help, you just have to tell me. I don't mind doing some extra problems next class. I don't. This class has been a little long, I would say. So make sure you do the problems from 3.1. Ask me to do some of them. I'll be happy to do them. Thank you, guys. Bye-bye.